Today's focus will be on nuclear reactions. The difference between a nuclear reaction and a chemical reaction is the nuclear reactions deal with the change in the nucleus, what's in the nucleus? Protons or neutrons. Okay, so we're changing something about the protons or neutron count, whereas a chemical reaction changes the electron count. With nuclear reactions, you always are releasing some sort of radiation, and there are 4 types of radiation that you're going to need to know: alpha, beta, gamma, and neutrons. One of these 4 particles will always be represented during a nuclear reaction for this class. Okay, so let's focus on the first one, which is an alpha particle. An alpha particle is the helium nucleus. Okay, so it's everything that makes up helium within the nucleus. So you're talking it has 2 protons and 2 neutrons, which means it has a mass of 4. Now, when you are dealing with these nuclear equations or nuclear reactions, the things are a little bit different. The top number represents its mass, so that's the same. And then the bottom number actually represents its charge. Okay, so in this case, if I was looking at this particle, okay, where it's 4 over 2 He, okay, I would say its mass is 4, its charge is positive 2 because I don't see a negative, and its symbol is He. You can also use the Greek symbol of alpha, but that doesn't tell you any of its specific numbers, which is 4 and 2. So I personally like doing this one much better. Okay, so what is its charge? It is a +2. Now the example that I want you to look at is what you're trying to do for when you're identifying the types of nuclear reactions. You are just trying to identify what type of radiation is found there. So the first one, you're looking for this alpha particle right here. So do we see this alpha particle in any of these guys? We do, obviously, at the end. So this would be alpha radiation. Okay. All right. Next one. An electron. Oh, one way that I want you to remember alpha particle, by the way, is the alpha. If you've ever heard of like an alpha dog is a he. Okay, so that's how you know it's helium. So alpha is helium. All right, beta. Beta is just a high energy electron. Okay, it's an electron with a lot of energy. So what is an electron? And that's how you get your symbol. So if you go back to some previous topics, what is the mass? Remember, the mass is always on top of an electron. Well, that one is 0. Remember, we never included in its mass because it doesn't really have much of one. And then what is the charge of an electron? It is a -1. And what would a good symbol of an electron be? Well, that would be E. And that's why we have its symbol as 0 over -1, E. Okay, or you could write the Greek letter for beta, which is a capital B with a little tail, like right there, if you don't see that tail right there. But once again, the problem with writing just a beta is that you don't actually know the numbers when you're trying to do these calculations later that you're going to have to do. So it's good to note alpha and beta, but in essence, it's really important to know these guys. Okay, how do I remember the beta is an electron? Beta is the one with the E in it. Okay, and so it is the electron. Okay, beta has the E, so it is the electron. What is the charge of an electron? A -1. Once again, we're going to try to find the particle. Oh, there it is. So it would be a beta radiation. All right, gamma. Gamma is just high energy radiation. It has no mass, it has no charge, it is just pure energy. Okay, so a gamma particle is, you do this like Y loopty thing, okay? And if it's nothing, it has a 0 mass, which means it has 0 charge. And that's it. How do I remember that gamma is 2 zeros? I noticed that gamma itself, the word, has 2 A's, 2 M's, so therefore it has 2 O's. Okay, so double A, double M, 00. Okay, and so when I'm looking for the charge, well, I look at the bottom and it has a 0, so that would be a 0 charge. All right, and then when I look at my example, there it is, my double zeros. And then the last one you're going to have to know is a neutron. And a neutron is just that. It's a neutron. So going back to previous topics, what would its symbol be? Well, its mass is 1, its charge is 0, and its symbol is a little n. So that's where we get our neutron symbol. Once again, what's the charge of a neutron? It is neutral, so therefore it is 0. And then you've got these guys right there that would make it a neutron radiation. All right. So these guys, because of their size and different amounts of energy, can do different things and penetrate different amounts. So an alpha particle is very dangerous when it gets inside you, but because it's so big with a mass of 4, you can literally stop it with a piece of paper or your hand. It can't actually penetrate. Alpha radiation cannot penetrate your hand. Now, if you were to ingest it by breathing it in or swallowing it or something like that, then it would be inside your body. So that would be a no bueno situation because it can't get out, right? So it can't get in and it can't get out once it's out in. So it takes a long time for it to get out. So you don't want the alpha particle to be ingested in you, but if you just cover yourself up, put a piece of paper in front of you, you're good on the alpha. Okay, and that's because it's so big. The next one is beta. Beta is able to go through a piece of paper, but it's stopped by some wood. Or if you look on the bottom diagram, it's stopped by some plastic. Okay, and then gamma, which is just that high energy, it has stopped through some concrete or lead. And it will be stopped by lead, but you need quite a big thickness of lead. And just to let you know, that's why when you guys are going to have your dental exams, they put that like vest over you, the lead vest, and that's to stop the x-rays from actually penetrating into your internal organs, like your heart and your lungs and things like that, while you are getting a dental x-ray. So that's why they try to cover you up a little bit, is so you can stop some of this radiation from exposing some of your internal organs. All right, so let's answer some of these questions. What one has the most penetrating power? Well, most penetrating power means that it can go through the most, so that would be your gamma. What stops a beta particle? So I'm going to find beta. Nope, not piece of paper. So I could say a piece of wood or a piece of plastic. Plastic or wood. Okay, and do the penetration powers of these particles make sense? Why or why not? Well, it's really based off of size. So the bigger things get stopped by things easier. Right? So because it can't get through those little holes that are found in these things. So it does make sense, and it's purely based off of size. All right, so now comes the last part, which is probably the most difficult for students, and that are these practice problems. Now, this is not a very difficult topic in itself, but you just really need to pay attention early on. All right, so let's try to figure out some of these problems. This deals with, this is a nuclear reaction, okay? How do I know? It's got these 2 numbers followed by a symbol, and then it's got these arrows and 2 numbers followed by a symbol, things like that, okay? This also deals with what we call the law of conservation of energy. Law of conservation of mass. What that means is that mass on the reactant side, mass can neither be created nor destroyed, is really what it says. But what that means is the mass you start with has to be the mass you end with, so mass end. And how do I separate what you start and what you end with? Well, you use that lovely little arrow, okay? So the left side of that arrow has to equal the right side of the arrow. So we're going to just do very basic algebra problems, okay? Now, where's the mass? Let's focus on that first. That's on the top, okay? So if I look at this, I'm going to do it like in a math problem, okay? So it's 242. Instead of thinking of it as an arrow, think of it as an equal sign. So I say 242, then the next thing I run to is this guy, so it's an equals. And then I see 4, then I see a plus, and then I see a blank. And I'm going to put that in because that's what I'm actually trying to solve for. I'm going to put it as an x. Okay? So now I'm going to subtract both sides, and I get 238 equals x. And I'll fill that in a minute. I just want to be able to show you all the math first. Okay, now we're going to deal with the bottom, because the bottom also has to add up to each other. So I've got 94. Instead of an arrow, I think of an equal sign. 2. Notice I'm just going left to right, filling in this stuff. Plus, got that plus. I'm going to say this is y. Okay, so now I'm going to subtract. I get 92 equals y. All right, so now just plugging this in, instead of x and y, what I'm going to do is I'm going to put in 238 for my top, 92 for my bottom. Okay, but what else do you notice about every single one of these? Well, they have a symbol after that. How do I get that symbol? Well, all you have to do is base it off your bottom number. And your bottom number is 92. So you're going to go to your periodic table and you're going to look up what atomic number is 92. why can I look at the atomic number being 92? Because the atomic number equals the number of protons, which equals your charge, right? But this, in this case, it represents your number of protons, so it'd be uranium. Okay, that's the first one. So it's 238 over 92U. All right, now let's try the next one. We have an X, okay, so I'm going to say this is X now. So I've got X arrow, which means equals 32. Notice once again, I'm just going left to right, plus 0. So we get 32 plus 0, X equals 32. Okay, so now I'm going to do the bottom. And so the bottom says Y equals 16 plus -1. 16 plus -1. So then Y equals 15. So my answer would be 32 over 15. I'm going to look at what 15 is on the periodic table, and 15 is P, so I would leave it like that. Okay, next one. A little bit trickier. Okay, same thing though, okay, but what there's a little bit more to it. So we're going to do 252 plus X equals, and this is where it gets tricky. Okay, what it's saying is it's saying when you have 3 of these guys, which is 3 neutrons. So it's really saying instead of 1 over 0n plus 1 over 0n plus 1 over 0n, they just combine it just like in algebra. You do x plus x plus x, you get 3x. And if you have neutron plus neutron plus neutron, you get 3 neutrons. Now if I added up all of these masses, what do I get? I get 3. What I can do though is take this big number and multiply it by that 1. So we're going to take 3 times 1, so it's contributing, this guy right here is contributing a mass of 3. Then we're going to do plus 259, okay? And so when we solve this, we're going to get 252 plus x equals 262. Subtract 252 and we get x equals 10. Okay, so I know that the top number is equal to 10. Let's try the bottom number now, which is y. Okay, so we've got 98 plus y equals, right, equals 3 times 0. So it would be 0 plus 103. So if I have 98 plus y equals 103, we are going to subtract 198, so we get y equals 5. Okay, so then I'm going to put in 5. And then what I want to do is look up what 5 is, which is B. Okay? All right, and the last one. Not too hard on the last one. We've got 55 plus x equals 55. Okay, so x equals 0. And then we've got on the bottom 26 plus y equals 25, because that equals 25. Okay, so y equals -1. So now when I put these guys in, there is no number on the periodic table that has a -1. Okay, so now you're going to have to draw from your types of particles. Okay, so what are those types again? You have the alpha, which is he. It's a boy, right? The alpha dog is a he, so you got your helium nucleus. That's alpha. Then you have your beta, which is 0 over -1e, because it is your electron. Then you've got your gamma, which is 0, 0, gamma, okay, like Y kind of thing. You got gamma. And then your last one is a neutron, which is the mass of 1, 0 charge neutron. All right, so now what we're going to try to do is if you're not able to find it on the periodic table, what you need to do is you need to figure this out based off of which one. It's just a matching game. So the only one with a 0 over -1 would be your beta. So this is going to be a symbol of an E. Because remember, these are nuclear particles, so they have to have one of those 4 in any of these. Okay, you're also going to have to be able to identify what types of reactions these are. Super easy. The top one, you're going to see it. Oh, that's an alpha. Okay, then this one on the next one, I see this beta. And then the next one, I see these neutrons. So you would identify it as a neutron reaction. And then this one would be a beta, which would be a beta reaction. All right. Hopefully you have a basic understanding of these different types of problems and the different types of particles that we'll run across in nuclear reactions. Have a great day.